right into what we've got planned for you today. I have two activities. I say two activities. As usual, there are two activities. The first thing we're going to do is going to be based, you see I've got my little area over here, it's going to be based on chemistry, yes, and using yeast. We used yeast last week, right, as an indicator of sugar in something. Great, I'm glad that you're able to hear me. Okay, so yes, we used yeast last week as an indicator of sugar being in something. This week we're going to do a little bit of a variation on the elephant toothpaste activity. Okay, and once again, I'm glad that you're joining me. I am Miss Steph of Triple F Empowerment Inc., and this is Saturday Science with Miss Steph. I hope that you enjoy your time with me. We are going to do some variations. You know, I like to have my three samples, right? So I've got my three samples today, and we're going to do three variations on it. The variations that we're going to do on our elephant toothpaste is just the order and the technique that we're adding the chemicals into our sample containers. That's what, let me make sure that you're able to see these, okay? The closer they are to me, the easier it's going to be for you to see me, okay? So once again, we're doing elephant toothpaste today, but we're going to switch up the order in which the materials are going to be added into our three containers. So for this activity, you see I've got three different beakers and they're all essentially the same size, okay? Just so that we'll be able to see the levels rise. We have down here, trust me, the experiment, if the, not experiment, but the chemical reaction goes well, you need this area to be covered. Then we've got some food coloring. We have our rapid rise yeast. We have our peroxide, which, yes, I know it's a little hard to come by these days, but if you're in one of the areas where you've got some left over, you can go ahead and use it for this fun science adventure. And my trusty dandy clear dish soap. Okay, so welcome to Saturday Science with Miss Steph. Let's go right ahead and launch right into this. So like I said, I'm going to do the same thing inside of all of these cups. I'll just be adding those things in different orders. So let's do this. I've got my materials back here. Thank you for joining. I see we've got a third person watching. Come on, people, go ahead and you might as well share it. Oh, a fourth person. What? Hey, come on. I'm so glad to see you. Welcome to Saturday Science with Miss Steph. So we're adding these in different orders. So what I'm going to do is actually label them by the first thing that's going in the container. All right, so yeast will be the first thing that will go in this container. Soap will be the first one in this container. And then food coloring. Food coloring will be the first one to go in this. And for all of them, this will be last. All right. So we've got our yeast. Okay. And again, that's the first thing that's going inside of this container because it's labeled yeast, right? For this particular activity today, the way that we're being scientists, the way that we're changing it up is the order, okay? The technique, the order that we're adding each material inside of the container, right? And then our first thing here is actually going to be soap. We're putting the soap down inside of here. I'm using 100 milliliter beakers. Once again, thank you so much for joining me. Okay, I've got my soap in there. And then here will be the food coloring. I'm going to put down the colors that I'll use for each. Okay, that'll be for later. All right, the food coloring is first in here. 1, 2, 3, 4, 5. Okay, same amount of food coloring. And then I'm going to kind of do like a round. So the next thing that goes inside of this cup is going to be the soap, right? The stuff that's left of it. I mean, to the right of it. My right, your left. Next thing that I'm putting in here is going to be food coloring. Okay, we're just doing a different order for how we're putting in the different materials. 1, 2, 3, 4, 5. Once again, the same materials will go inside, same chemicals will go inside of each container, but they're going in a different order. Okay, food coloring. So then soap is the next thing that goes here. Okay, and then so now we need to do yeast in here, right? And finally yeast in here. Okay, and then in here we'll do our food coloring. 1, 2, 3, 4, 5. I like to use different colors for each sample so that you get you have an easy, quick little like color coding. That's why I'm using different colors for each sample, just so that you can see, like quickly notice the differences, right? So once again, today we're doing a little bit of a variation on the infamous elephant toothpaste. And the materials that we're using for that are food coloring, the rapid rise yeast. You can get this on your next grocery store run if you weren't able to grab some of it before coming on today. Clear dish soap is actually going to be best, just to be honest with you. It's easiest to use the clear because, frankly, it doesn't alter the chemical reaction. And then, of course, we've got our peroxide. And the highest percentage that you're going to get here, this is just your 3%. But there's some other versions of peroxide that you can obtain, but this is the one that I'm using. All right. Now, we added inside of each cup the same materials, but we're changing the order that they are going inside of the cup or beaker, right? We know it's a beaker because it's got some labeling on it and also the shape, this part right here, okay? And like I promised, all 3 of these things have gone in. And then last thing that we're going to add is our peroxide, our hydrogen peroxide. And as you see, I just have CVS brand, nothing special, right? So inside of each of these, I'm going to do 30 milliliters because I can tell that I'm running low and I want to make sure that there's enough and I want to make sure that it's even. Now, typically to measure, right, the right thing that we do when we measure is we come down low and we come to the proper level. I'm not going to do that with you today because then you won't be able to see what I'm doing. So I'm going to go ahead and hold this up for you. All right. Pour. And stop. Like I said, I'm going to 30 milliliters. I've added the materials, the same materials, just in a different order. And I'm adding the same volume of peroxide to each container. Are you noticing already, which I hope you are, right? Like, can't you tell? You should be noticing already that we've got some differences, some major differences. Okay? Same 1, 2, 3, 4 chemicals. Okay? And at the fundamental level, same chemical reaction, but the speed and the size of that reaction, okay, gets changed up by the order that I'm putting these things in here, okay? And as you can see, now you see why I needed my paper towel, all right? So with the yeast first, and then the soap, and then the food coloring on top. The food coloring mixed in better with this, and so we're getting a nice blue color, but it's not making contact with the yeast as easily, so it's a little harder for it to react, because the yeast and the peroxide are the two main things in this activity, okay? Those are the two things that are mixing together, and then the soap and the food coloring are then helping us be able to see what's happening, and it's so awesome. So the yeast was the last thing that we added here. Okay, the yeast was on top. And so it made quick contact with our hydrogen peroxide. Okay, however, not as good as contact with our food coloring. The food coloring is kind of trapped under our dish soap, which changes surface tension, which captures things, right? Okay, so the food coloring is kind of locked in under all of that, okay? And I'm only getting this little bit. Then now over here, the reaction, as you can see, is still happening, but it's a lot slower, because my yeast is kind of a little trapped inside of different things, okay? But all of the containers, by the way, are warm, okay? All of them are warm, all right? And so let's bring you a little closer to everything. So, okay, so this is the one that had the food coloring go down first. And then I added some other things. This is the one that had the food coloring go down kind of in between some layers. Okay. And then this is the one that had the food coloring actually go last with the yeast first. And so you see the yeast, let me turn this way. Make sure you're able to really see it. That yeast layer, there's a yeast layer here. So the yeast is really having trouble to getting a chance to fully react. Well, not trouble, it's inhibited, right? So it's going a little slower. I mean, it's still reacting, okay? But just a little bit slower. And then this one, we got this quick thing, but the bubbles, the foam is not holding up as well. So once again, this was a quick little variation on elephant toothpaste, right? So you can see that as scientists, it's really important for us to understand that the order in which we add materials to our reaction chambers, okay, to our samples, can have an effect on the size and the speed of our final reaction, right? So let's review our materials very quickly before we move on to the next thing that we're going to do, okay? We used 3 beakers that were all the same size. They're 100 milliliter beakers. We used some just standard hydrogen peroxide that I got from CVS, as you could tell. And any store brand will work. I used this clear dish soap, because the dish soap being clear means it's not going to interfere with the color or anything of the reaction. I used some just run-of-the-mill food coloring, all right? And our rapid rise yeast, okay? As far as the brand, this is the brand that's almost always in the store when I go. So I don't really tend to have too many options as far as what brand that I use. But I really encourage you to try this at home. Just keep in mind that the containers are going to be a little warm, okay? You definitely don't want to be trying to smell this. Because remember, last week we talked about how yeast produce a smell when they're reacting, when it's reacting and so forth, okay? And definitely dispose of this very quickly after you've completed your activity because, like I said, it's going to smell and it will start to like really have potential to make a very big mess. And sometimes we make a mess in science by accident, but let's not do that, right? So I'm going to put these to the side and break out my next activity, which is an art activity, folks. For those of you who know me and know how we are at Miss Steph's Science Club, we love art. We truly believe that art and science um, do go together and that you learn quite a bit from trying to do different art projects, and you learn and you get an opportunity to see the major importance in all walks of life as far of chemistry and science and the different types of science, right? And so just give me a quick little moment. I'm trying to clean this up quickly because we are live. Try to make sure these transitions are quick change transitions, right? For my performers out there, quick change, you know the importance of quick change. Okay. So now let's bring over our art activity. In here, I have water. That's all that's in here right now. As you can see kind of on the sides, I've used this particular bin for this activity in the past. So when you're doing this activity, I strongly, strongly, strongly recommend that you do it in a container where you're not going to need to it to be like completely be able to be completely cleaned. Again, because the chemicals, these particular chemicals actually stay in there. So it's definitely not something you want to use inside of something that someone's going to need to eat out of ever. Okay? You definitely want to make sure that you're using a container that's for art, okay, or for your science, and not to be used for food. Absolutely not. You want to be really careful with that. All right, so to kind of continue our theme that we started last week, right? Last week we did some stuff with yeast, and we also did marbleized paper. And I told you that I have lots of different ways to do marbleized paper and to make lots of paper art. And so we're continuing with that again today. All right. And once again, I'm Miss Steph, and you are joining me for Saturday Science with Miss Steph. And I definitely encourage you and invite you to join me, of course, on this conduit on Facebook live next week at 2:30 p.m. Eastern Standard Time, as well as on Wednesday afternoons. And of course, definitely feel free to share this with your friends and family so that they know about this awesome free science project ideas for children. Okay. So I'm going to actually put my food coloring down first. Remember, I promised you earlier when I did the audio test, right? I promised you that we were going to actually try to use several different materials. Okay, different methods and materials. The reason that I do that is so that you feel like it's accessible. You feel like this is something you can try at home because maybe you don't have the materials that I have. I have a lot of materials in the cabinets because I'm a science teacher, just in case you didn't catch that. And so I have a bunch of different things that I have in my home, and I have a great time mixing things together and seeing what happens. But I definitely want to make sure that everybody has an opportunity to try, um, you know, try the activities that I'm doing in their own homes, right? Since a lot of us are spending quite a bit of time at home. And in New York today, it's a little rainy, okay? So once again, I'm using different things so that you can get some fun science ideas, fun art ideas, and so that you feel like it's something you can try in your own home. So let's go ahead and put down the food coloring. Similar to last week, I am not going to put the drops close to each other. I want them to be separate. Okay. So I'm going to put the food coloring down. Okay. And the portion of this that stays on top, all right, the portion of the food coloring that floats is what should come out on our paper. Okay? Last week we used shaving cream, right? And I definitely encourage you to go back to look at that video if you want to try to do this with shaving cream instead of this water thing. Okay? So I'm going to drop this down there. All right? Okay? So you see it's very, very light. Okay? Very light, just a little something there. Okay? Light little impression. And that's what happens with the food coloring. Now, okay? And there's different reasons why, right? Because food coloring mixes with water instead of floats on water. What if I used food coloring that was in gel form, right? What do you think would happen? Anybody in the comments, what do you think would happen if I used gel form food coloring where you have more of it stick on the top and so forth? So think about that while I get ready to put my other types of chemicals down. Okay. Like I said, this stuff is really similar to, it's a special kind of like ink. And it smells a lot like fingernail polish. So if you wanted to try this at home and you're like, but Miss Steph, I can't get that. If you've got some fingernail polish, and it's a little fingernail polish remover, and again, this is definitely not something that you want to do just kids by themselves. This is parent supervision activity. Okay. But yeah, so I'm gonna put some of this down. Okay. And we'll observe the difference between how the food coloring, the regular food coloring reacted, and how these particular pigments are going to show up on the paper, and therefore really let you notice the differences in those chemicals, right? Because like if they react differently to water or the same to water, that lets you know how similar they are on a molecular level, right? So I'm just putting this down. I'm going to stop there. All right, get my paper towel ready so that I have somewhere to put my piece of art. Right, same method. I'm not doing anything different, just dropping it down. Okay, I'm gonna grab this. Okay. Do we see how different that is, right? Major difference. So there's the art aspect to it of like how cool it is and all that types of stuff. But then the chemistry part of this, right? The physical science of this is like, oh, so these pigments must be different from here, like as far as the molecules, as far as the chemicals that are inside of there, they must be different because they produce a different, reaction to the water and the paper. Like something different happens, right? Like for example, if we're mixing baking soda and water together, compared to baking soda and vinegar, those things give a different reaction. So even though vinegar and water look really similar, right? even though this green and this might look similar, okay, when I show you how it reacts to something else, that lets you know that that's a different chemical. So yeah, so let's make one more before we finish our time together today. All right. Once again, if you're wanting something more similar to how these work, our marbleized inks, you can try um, fingernail polish on top of water, okay? And you can kind of thin it out with some polish remover, right? Doesn't that make sense chemically? A polish remover thins out fingernail polish, right? That's how you get it to come off. You're breaking it down, right? Putting this down. I'm looking at it. It looks so cool. And then I'm moving it and picking it up. Right? Awesome. So some of you might be saying, okay, but Miss Steph, I don't have these like pigments at home. I don't have fingernail polish remover. I don't have any of that stuff at home. But maybe you can get some gel food coloring. Okay? So what I think I should do is do a quick test with my gel food coloring for you so that you can notice how that reacts with the water and to find out whether or not that is going to do what you want it to do. So give me 2 seconds. I'll be right back. Uh-oh. I told you there's a lot of stuff in the cabinets. All I had to do was just go to the cabinets, right? And of course, let's break out my favorite color. I have 2 favorite colors, by the way. It's just that most people just know about the purple because I'm ridiculously obsessed with purple. But my second favorite color happens to be orange. So let's put some orange. And you notice, no, I'm not changing the water. I'm not changing the water. Okay? Because 1, we don't have time for that. And 2, it's not about the, the water. It's about what floats on top of the water. Okay? And again, this may or may not work. I just want to show you so that you can see it and find out what would happen. And maybe it would give you some ideas of things to try. Okay? And also think about, especially for those of you who saw last week's episode, think about the difference between our water base and our shaving cream base, right? When we're doing our marbleized paper. Okay? So I'm going to put this down. Once again, this might not work. Is that okay? It's science. It's totally fine. That's fun. So you notice we actually got some remnants of everything. So I got a little bit of the food coloring that was there before. I have a little bit, you see my purple dot there in the middle. I've got a little bit of everything happening there, So it didn't work perfectly, obviously. And yes, I kind of knew it was going to work that way, but I wanted to show you what might happen. I even have a little droplets of orange. So yeah, let me start to clean up here, and as I start to clean up, I'm going to chit-chat with you. All right, so thank you. First of all, thank you so much for joining me today for Saturday Science with Miss Steph. In the description box or whatnot, after I publish this, I'll make sure that I put up the materials, right, so that you know everything that we used. Okay, we are rather me and you, together, the things that we used. Um, and also, um, just kind of give you an idea of what you might want to try at home, right? Like I used these things, okay? These are our marbleized ink. Let me find the box. I don't see the box. Right. But this is what I used, okay? If the art store is kind of starting to open up for like pickup and stuff, you might want to grab those if you want to, okay? And that's what I used for that. And you notice that for the method that I used today, the those gave us the best results. And that's because the pigment actually floats on top of the water. It doesn't mix with the water, but it's similar to like oil and it floats on top of the water. Okay? And we noticed that the food coloring, this liquid food coloring kind of was okay, right? It didn't give us, high pigmentation, didn't give us a lot of control, right? It didn't really pop, this is what it looked like. Yeah. And then our gel food coloring at the end gave us just kind of a mix of everything, So you get the most control if you use the easy marble. And for what we did at the beginning, our elephant toothpaste variation, right? We used soap. I'm moving this here so that it's not distracting. Okay. We used soap, hydrogen peroxide, yeast, food coloring, and then beakers that were all the same size so that we could compare an even amount of peroxide inside of the containers. And we put our peroxide, soap, and yeast and food coloring inside of the containers at different times, right? And so in different order, And so we were able to observe that the order that you put your chemicals inside of your reaction vessel actually does make a difference. Well, guys, thank you so much for joining me today for Saturday Science with Ms. Steph. I look forward to seeing you right here on Facebook Live next week at 2:30 p.m. Eastern Standard Time. And feel free to share this information with your friends and family. And definitely, especially if it takes away off of me, definitely, please feel free to send me a message or in the comments request an activity from our good friends, the Cabbies. Have a wonderful Memorial Day weekend and be blessed and be safe. Thank you so much.